Hi, this is Chad Balewell. In this video, I'm going to show you some design patterns that you can use for Android app development. I've used these design patterns in the coju.mobi apps that I've built. There are 26 apps under the coju.mobi name. This specific app is the flagship app called Koju. It has over 50,000 downloads. So what I've basically done is this is the main app project which uses two libraries, one for contacts and one for support. This contact library is also used by a lot of the other contacts app that I have under coju.mobi. So just to show you the build.gradle file for contacts and support, these are library modules. Uh, they have to have this at the top that denotes that this is a library and not an application. So if the plugin type is a com.android library, this is how it should be stated. Contrary to this, this is my app here where the plugin type is an application. So I try to build as much common code in my libraries and have minimalistic code at the application level. So just to show you, if I expand my Java code, I basically have only two classes called activity main and one for cloud messaging service. Cloud messaging service essentially links with the Firebase messaging, and it is important, or rather, I'll say it's complex to put it on a shared library which could be shared across applications. So I create one class for each application that I have. The activity main is where this is the main launcher of the class. So I have some basic definitions for specifically for that app defined here. But as you see, activity main actually extends from another class called activity base main, which now is defined in my shared library. So if I go here, this is the activity base main. Now in this case, activity base main in turn is also a derived class uh, from another class called activity base add that basically takes care of serving ads. But we really do not have to create an interface hierarchy at that level. So here in my contacts library project, I have a lot of these activities that are shared across multiple applications. So if I'm creating an app main, say for contacts backup um, or importing contacts, I do not have to use all the other activities. I can just use one of these activities in whichever app I want. Now, these are independent activities, they can stand by themselves, and the only thing you need to take care of that you have the required permission in the manifest file. Another thing I do is I follow a model view model pattern. So essentially all my data read write, in this case I'm reading data from the contacts database actually inside the model class. So I essentially have all the CRUD operations defined. So I have a separate class for creating contacts, one for deleting contacts, one for reading, and one for updating contacts. In this case, the read contacts is the most used class, so it will have several functions inside it. But no IO operation from the contacts database is done outside these class. So these help me to localize all the IO operations, and if there's a problem, I know exactly where to look. This model class communicates with the view model class. So for most of the activities, I have a view model class assigned to an activity. But the main one in this case is the view model contacts display that takes care of displaying all the contacts in like a list view and allowing the user to select or launch a window that shows the contact details. So this in turn, this view model class actually uses objects of the model class. So in this case, I mainly do read and update operations, which I've defined here. So in the constructor of this view model class, I'm going to instantiate the model contacts read and the model contacts update. So this way, all my communication from my activity to my model class has to be routed through the view model class. In the view model, I also add some business logic, or if I have to modify the data, all that happens at this layer. All the activity has to do, so in this case, the activity base main, if I search for view model. So here I have declared the protected variable called VM contacts, which is of the type view model contacts display, which is the view model for the specific activity. Now the actual instantiation of this can be done inside the base class, which is the activity base main. In this specific case, I instantiate this in the activity main class. What I do is I have this function called set local variables and event handlers that gets called as soon as this activity is instantiated. So if you go here, uh, this is the onCreate function of the activity, and I go down, the set local variables and event handlers are called. Another thing that can be done here is you can create the set local variables and event handlers in the base class, and you can move this functionality if this is a common functionality that can be shared with other applications. And if you need to do something specific to your app, you can override this function. But in this case, since I have this function only in this specific activity, I have not declared it in the base class. So let me go again. So as you can see here, I instantiate the VM contacts. Now the actual declaration of VM contacts, as I showed you earlier, is in the base class, which was, if I go here, it's defined in the activity base main, which is what activity main derives from. So this way, every function that needs the view model can access them through this instance. This also allows me to actually share this instance of VM contacts with other activities. For example, I need to use the instance of the view model contacts display in another activity. All I do is just call the get instance function. Now the get instance function is a static function. Let me go back to the class. Uh, and this is where the actual instance of the view model is instantiated. So the view model is treated like a singleton here. So I'm following the singleton design pattern. And the constructor is going to be private. So there's no way to instantiate a view model apart from going through the get instance class. Now in this case, forcing it to be a singleton allow me to share the same instance and the same state with multiple activities. This is a point of discussion, and some people think this is not exactly the best way of doing it. But I think if a singleton allows you to share the state, there's no harm in it as long as you remember to clean it up, which essentially the Java garbage collector does automatically when the activity where this is instantiated is closed. So it's very important that all the cleanup and all is done very correctly. Generally, when you are sharing objects of activities, that is when most of the problems with memory leakage comes. But if you are sharing more like custom defined class which do not contain any UI and only deal with your business logic, then it's fine to do it. But again, just like as with everything in software, people have multiple opinions. So I'm just showing you what really works well for me. I have not had issues where sharing a singleton has led to any memory problems, and this kind of a pattern is running in 26 apps. Most of my crash reports on the Google App Store are because of the in-app purchases API, which again has been a point of a source of problems for me for quite a while. Anyway, continuing forward, these are the view models that I have. For example, this is a view model that removed duplicate contacts. This is a view model that handles all the export. None of the view models have any user interface with them. They mainly deal with the functionality, and also they deal with message parsing. So say my model, in this case, let's take for example, I'm deleting contacts and I have to delete 100 contacts while my UI has to be very responsive. So I will, every contact I delete, I will trigger a message that can go up till my UI layer to tell the user what contact was deleted and how many are remaining. So the view model also serves as a broker for message passing between the model and the user interface. Anyway, that's it for now. I'll show you some more design patterns that I've used in other videos. Thank you for watching.